Alright, let's do a problem that you revolve around something besides the x-axis or y-axis. So, I think 27 in your assignment. So if you want to look at it, it says you're going to, given the space, y equals the square root of 2. And I have y equals secant x tangent x, and the y-axis. So this area, we're going to revolve that around the line y equals the square root of 2. Okay, I think this is number 27 in your set. Okay, so first thing you should do is recognize what type of a technique we're going to use. Is this going to be hollow or completely solid?
Solid.
Do you see that it's going to be solid? So this is going to be revolved, it's going to have like a bullet sort of thing. You see that? So it is going to be of the form pi r squared. Are we integrating with respect to x or y?
Y.
No y. No x.
Square root of 2.
We've got it narrowed down, don't we? It's either x or y.
Well,
Hey, since it's a horizontal axis of revolution and we're using the disk method, it would be with respect to x.
called that trade.
Okay, so we just need to figure out what our radius is. Here's my radius right here. There's r. Okay, we're going to revolve it. That's what it's going to look like. So how do I represent r?
Secant x minus square root of 2 minus secant x.
Okay, so how big is this right here?
Secant x.
You could say it's y, or you could say it's secant x tangent x, right? Do you agree with that?
Yes.
Okay, so we want this much. How tall is this whole thing? Square root of 2. So this would be what Lincoln said. Square root of 2 minus this much. So this is the square root of 2 minus y. What's wrong with that?
It's not respect to x.
Correct. So we want y in terms of x. So it is also square root of 2 minus secant x tangent x.
How did you not put it in terms of x?
Because you have a horizontal axis of revolution using the disk method.
Oh.
In other words, if that's one partition, the next one's going to be right here, right? Then it's going to be right here. It's going to be right here. So my change is in x.
Oh.
So you know that you're integrating with respect to x. So we're going from 0 to whatever that is. So we need to find that solution. This does not look like much fun. So I'd use your calculator to find the point of intersection, and then I would use your calculator to evaluate this integral. Don't bother. A lot of them, this probably could be done by hand. Don't bother with this one. So whatever this turns out to be, give you this.
Couldn't you just simplify with trig and then
Simplify what?
simplify with trig and then cosine squared and then cosine
You would have
squared
to, yeah.
1 over square root of 2 square root of 4.
I didn't even try it.
How do you do that on the
Yeah.
number?
The top number? You'd have to graph y equals the square root of x, or square root of 2. Graph y equals secant x tangent x, find their point of intersection.
Okay.
Good question.
Oh, the top of it.
Yeah.
Okay, so this is something we probably, or at least could have done on Friday. That's not a new technique. That's a disk method. It's just an axis of revolution that is not an x-axis or a y-axis. Okay, so let's try one using the shell method.